In Verilog, there are more loops as compared to its programming language counterpart. In today's episode, we will unveil them all. Also, we'll make you familiar with the break statement to break out of any loop in Verilog. To know in detail, stay tuned till the end of this video. Hey guys, welcome back. In today's episode, we will cover the below points. First, we will talk about the for loop in Verilog. Next, we will go through two different examples of it. Next, we will talk about a different kind of loop which you will find in Verilog only, that is forever loop, and we also give its example. Next, we will go through the while loop syntax, and we also cover 4 different examples of the while loop. Next, we will talk about the repeat loop, which is very much exclusive to Verilog, and we will also give 3 different examples of the repeat loop. Next, we will talk about the disable command, which is the C style break statement in Verilog. So that's the menu for today. So without any further delay, let's begin. For loop. Similar to for loops in C or C++, they are used to repeatedly execute a statement or block of statements. So for loop is very much familiar to you from your learning in C or C++. I think that is the first programming language nowadays anybody learns at the school. If the loop contains only one statement, the begin and end statements may be omitted. So this is a single statement for loop. Next, it controls execution of the associated statements by a 3-step process, which is as follows. First, executes an assignment normally used to initialize a variable that controls the number of loops executed. This is the counter variable that we are very much familiar with the C. Here the syntax is very same. Next, evaluates an expression. If it is 0, the loop shall exit. If it is not, for the loop shall execute its associated statements and then perform step C. If the expression evaluates to an unknown or high impedance value, it shall be treated as 0. Now, execute an assignment normally used to modify the value of the loop control variable. Then it repeats step B. So this is a plain and simple explanation how the for loop operates, and it is very much similar to the conventional for loop that you have learned in C or C++. However, there is a little bit of difference because it's digital and it has some logic which we can see here, the high impedance value, which is kind of very much native to the Verilog only. We are done with this particular slide. Let's move on to the next slide for examples. For loop example 1. So here we will go through the example. First, the for loop implements the logic while only 2 lines as shown in the pseudocode below. So this is kind of structural example, not the code example. So this is that. This 2 lines, so that means for, and then it call this also the syntax, right? Initial assignment here, then the condition, and then the step assignment, whether this step is increasing, it is going up, or it is going down. This kind of increment counter is here. So this is step assignment. A condition is the checking condition. It keeps on checking and validates that the condition is valid or true. Only then the for loop proceeds for the next iteration. Otherwise it exits. And initial is the initialization. Okay, here goes our statement. This is a single statement. Multiple statement should be contained with a begin here and a end here. So this is for the for syntax, or you can say this is the pseudocode. So here starts our example. You can see we have a counter variable I equal to 0, which is initialized, and then this is the checking counter. So this has to be validated. As soon as I becomes 7, the loop breaks out. And here we start I equal to I plus 1. This is a increment counter. So the value will increase over time. Next, we initialize. This is a bit assignment. So here we initialize the bit of the memory ith bit to the 0. And it is another example. Here the counter variable is I again, and here I is less than equal to bit width, and here we also have the incremental counter I equal to I plus 1, and for that we have another statement inside which is kind of different from this one. Here we have a if this condition is true, then we have out equal to out plus our expression is here, and this is used for multiplier using shift and left and then AND. We are not going to the design details here. Our purpose here is to get familiarized how the for loop is written in Verilog. So I think the syntax and the two examples you are very much familiar now. We are done with this particular slide. Let's move on to the next slide. For loop example 2. Now here we start a 32-bit full adder. I'm not going in the design detail. This is for your learning purpose of the how the for loop works, because in case you are not seeing the example, it is very difficult for you to write any code, whether it is Verilog or whether it is any other language. It is a must for you that you go ahead and see the different examples, get familiarized with the coding style or the writing style, and then you become fluent in writing the code. Here we start our always. Then we have begin, and for n equal to 0, n less than 32, n plus plus, we have the begin. So you can see here we have the begin because it's a multiple statements are coming here, and then we have sum expression. This is the sum expression, and then we have the carry expression here. So here we end our for loop. So for loop starts here and it ends here, and here we end our always block with the corresponding begin and end. So here we are done with the second example. We are done with this particular slide. So let's move on to the next slide. Forever loop. This continuously executes a statement. This forever loop is a different concept from the for loop which you have seen in other programming language. So for loop you have seen in C, Java or something in other language. However, the forever is a kind of different loop which is native to the Verilog. Now in detail, the forever statement executes an infinite loop of a statement or block of statements. To avoid combinational feedback during synthesis, a forever loop must be broken with an @ or negage of clock statement. For simulation, a delay inside the loop will suffice. If the loop contains only one statement, the begin and end statements may be omitted. So this is a style where we have only a single statement inside a loop. You can find this common over the all loops here in this particular video. So this is an important thing. We will exemplify it. Don't worry. Here the syntax of the forever loop is forever, begin, then we have statements and we have end. So this way the forever loop works. Now we are done with the definition and the syntax here. So let's move on to the next slide for example. Forever loop example. We have forever begin. We have begin since we have multiple statements coming here, and then we have @ of clock. So this happens only at the of clock, and then we have the statements a equal to a plus 1. And we have end. So this end corresponds this begin. Here it is very plain and simple. Next we have another example, forever. Then we have @ negage of clock, and we have the statement here. Now this should be used with disable or timing control. So here we are done with the forever examples. So here we are done with the particular slide. So let's move on to the next slide. While loop. So here we go for our details for the definition, etc. The while loop repeatedly executes a statement or block of statements until the expression in the while statement evaluates to false. So this is a kind of statement that we understand in any programming language, and we are very plain and simple about that. Next, to avoid combinational feedback during synthesis, a while loop must be broken with an or negage of clock statement. So this is very specific to the Verilog while you are coding in Verilog. Next, for simulation, a delay inside the loop will suffice. If the loop contains only one statement, the begin and end statements may be omitted. So this is, you will see in every loop we are talking here in this particular video. So this is a common statement. Now we are proceeding for the next point. So here we will see the syntax. Syntax is while we have a expression, this has to be true. And then we have begin and the statements here which will be executed inside the while loop, and we end it. This begin and this end ensures there are multiple statements here. We are done with the definition and syntax of while loop, and let us proceed for its example. So here in this single slide we will cover 3 examples of the while loop. First one, this is example 1, and we start with define a register with 7 down to 0 and the name is temp reg. and we have a count 0. So we are not going in the design details or talking about that. We are just exemplifying the syntax by the Verilog code, so that your hand is very much free to write the Verilog code. Now we have temp reg, we give it to reg A, and then we have the while loop, and here we have the checking counter, so this has to be true, temp reg, and we have begin here. So here start if temp reg 0 is equal to 1, then we have this expression, this has to execute, count equal to count plus 1, and then we have temp reg equal to temp reg, we have a bit shift operation here, and here we end the while loop. So this is the end corresponding to this begin. Here we have seen the while loop, and inside we have a if and all these operations that you can write. So this is a simple example of the while loop code example. It is not a design example, it's a code example here, so that you are familiar with the writing the Verilog code. We go for the second example. So this is example 2, and here we have the while delay has to be true, and we have begin, and we have a @ passage of clock. So this we have talked about in the earlier slides. This is for the passage of clock, so that has to go. And then we have this statement that we have, this executes once we enter this while loop. And the next statement is this, because this is, we are not giving a design example. In your case this will be a proper design statement. Here it is just an example of the while loop. This is the style how you write the Verilog code so that you can apply them. Here we end our while loop, and this end correspond to this begin. In earlier slides we have talked about this passage of clock can be included here, right? And we have exemplified it here. Now we are going for the third one, example 3. Here we have while not overflow. So this is the inverted logic. So overflow 0, and then we have a bang in front of it to make it a true. So we begin it, and then we have @ of clock. So here we have seen the passage of clock, and here we have the negage of clock, and then we have a equal to a plus 1, and we have end. So here this is a kind of another direct assignment here. So here you can see that we have exemplified both the negage and the passage of clock along with the while. So here we are done with the slide. Let's move on to the next slide. The fourth example of the while loop. Here we have the example 4, and here we have a range which is 15 down to 0 for buffer, and we have integer k, and always passage of clock. Here we have begin, we have k8, and while k is true, we keep the while loop running. So here store data at passage of next 8 clocks. So here we have begin, and we have k equal to k minus 1, and then we have passage of clock buffer k equal to data. Now here we end. So this is the start and end of the while loop. So here the buffer is 7 down to 0, and here we end it. So this is a very plain and simple while loop example, so you can understand it. And here you can see both the always block is sensitized with the passage of clock, and the while loop is sensitized with the passage of clock. So here we are done with the example. So here we are done with this particular slide. Let's move on to the next slide. Repeat loop. Now here in the single slide we will talk about a repeat loop, and we will give its example. The repeat loop, this name is very new to you. As the forever loop you have find only in the Verilog. Similarly you find the repeat loop in Verilog only, so it's native to the Verilog only. So I think in earlier any language like C or something you have not seen the repeat loop. So this is very native concept to the Verilog. So here it executes a statement for a fixed number of times. So this means it repeats a fixed number of times. We don't have conditions, so we have only say 10 times repetition or 5 times repetition. This way fixed the constant number of repetition. If the expression evaluates to unknown or high impedance, it shall be treated as 0, and no statement shall be executed. This is a native conditional checking for the repeat loop. Next, this is non-synthesizable. So this is the most important part while you are using. So keep in mind this is non-synthesizable. That means you cannot use it for a synthesized process, and you cannot use a commercial synthesized tool here to get something from the repeat loop. So you will not get anything. So here we have the parameter size 8 and long size 16. So these are two parameters we are defining. These are just constant. So parameter is nothing but a constant. We will talk about all these data types and all in some other episodes where we will talk about all these data types and all in detail. For now you see this example, and here we have the range defined with the, here also you can see that we have OPA, OPB and result. So here we also have another thing defined. So letting clear the marking. So you have seen all these things have been defined. So I'm not going in the design details. It's just a code example so that you get familiar with the coding style. And here we have initialized this thing, and similarly we have initialized these things here. And here we start the repeat loop. Here is the how many times you have to repeat. Size is 8, so this repeat loop will repeat 8 times. So here we begin loop with the begin command, and here we have the if condition, and corresponding action is taken here, and we have the another expression. Similarly here the third, and finally we end our repeat loop here. This end corresponds to this begin. So you can see that we have a fixed number of times, that is 8 times we will repeat, and we give that number here. If we change here, right, the number will change here. So this will repeat 8 times. This way you can have a controlled execution of a loop. Repeat loop is a kind of controlled execution. We are done here with the first example. We have the second example now. So here repeat bit width, and we have the begin, and then we have the if condition. It's a single line if, or the inline if. If this is true, then this will be executed. So here p equal to, we have a bit shift operation, and here this one, and here we end it. So we have here the second example of the repeat. So since all these statements are contained, so we use begin and end. If there is only one statement coming here, we would have not used the begin and end here. So since this is not a design example, it is just the coding style, you can see. So here we have a inline if. The entire if thing is ended here, and rest of the statements are part of the repeat only. We are done with the two examples of the repeat loop here in this particular slide. So let's move on to the next slide. Repeat loop example. So here we are going to see the third example. We have parameters defined, cycles equal to 8, and we have counter, right? So this is the repeat loop counter, and we have defined the buffer, right? We have integer, right? And we have always pausage of clock, and then we have the begin and k equal to 0, and we have repeat, then cycles. So here we have defined cycles, and here we have used it, and here store data at the pausage of next 8 clocks, and here we begin. So here we have our at the rate pausage of clock. We have the statement where we are storing the data, right? We have k equal to k plus 1 and end, and then we have the end. So this end ends the repeat, right? And this end ends the always. You can see we have used both pausage here and pausage here, that is of the clock, and we have multiple statement inside the repeat, as well as we have multiple statement inside the always. So we have, in both case, we have used the begin and end, and here also begin and end. So here we are done with the particular slide. Let's move on to the next slide. Disable the break statement. Now we have came across multiple loops here. However, we have not seen any of the break statements used in Verilog. However, in Verilog, the breaking style or the break statement is a different, and that is called the disable statement. Here we will see how to use it. Now, execution of a disable statement terminates a block and passes the control to the next statement after that block. And it is like the C-like break statement, except it can terminate any loop, not just one in which it appears. So it is much more powerful than the C break statement, and you will see in the example how it is powerful. I'll explain then. Disable statement can only be used with named blocks. So this is another good point. The named blocks are terminated using the disable statement. Otherwise, if you don't have a named block, cannot terminate. So far, we have not gone in very detail of naming block. However, this is very easy in this particular slide only with an example how to name a block. And here the statement, and here the syntax is the disable, then the block name. Here we begin a block. So this begin could be a begin of any of the loop, and here we have the accumulate word, and then we have the forever, and then we begin, and then we have at the rate pausage of clock, and a equal to a1, a equal to a plus 1, and here we have a if condition. If this is true, then disable the accumulate. We have not ended the accumulate block, so we have started the accumulate block, and everything inside it is under this accumulate block. And here we end means here we end the forever one, and here we end means we end the accumulate block. Now let me clear the markings. Now in this particular statement, you will see that if this condition happens, then this particular block, not only this forever one, this particular block, the entire block stops operate and the execution goes to the next line of code or something like that, or however the code is organized. Just you to use the disable statement, right? You have to use begin, then you give a name to it, the block on which you have to operate, and then you end the block with the end keyword. So begin and end here used for naming a block, and that block can be terminated using the break statement, and this is used like the C break statement in Verilog in any of the loop so far we have discussed. Here we have exemplified with the forever. However, you can go ahead use it with any other block. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.